Looks like that's about to start. So let me make sure I've got the right screen on here. It looks like I do. This is a Windows console app, and inside of it, I've attached up Veldred. Veldred is a framework, a library built in, well, at least it's available for C#. I'm not sure what it was built in, that allows me to call on Direct3D, Vulkan, OpenGL, and other rendering systems. And the principle of what I'm going after right now is that I can effectively just get rid of Unity altogether. And so this is my first test class. So when it worked, and I was thrilled that this thing worked. I thought that was awesome. It's really simple. Like right now I have an inverted cube playing, which basically means it's a normal cube, but all the faces are pointed the wrong direction. I forgot that I actually had that one on there. So let's put this one back. Control KU, and I'll set this back up the right way. Control KC. There, and now run. All right. So here's the normal cube. So this ran quick and easy. Now, quick and easy, I don't understand a lot of the code that I've put into here so far. I actually used AI to generate the initial stuff just to kind of see how do you get this going in the first place. Now, it built out 5 different class files for a console app, and it didn't work. I had to go through probably about 30 different iterations with it before I got it working in the first place to actually render something on the screen. Because it just kept getting things wrong, including referencing its own code. So it generated a class that it then referenced and then gave different parameters to it than what it actually created in the class. Anyway, but now that I have a functional system in here, the rest of what I'm doing now is just all intended to study. So I need to study how this works. Let's see. I suppose one thing I also want to do is get rid of the additional faces. Now let's just keep the front face for now. Control KU. Whoa, no. Control KC. And the front face. Control KC. Now, did I have numbers on the rest of this? No, because it constructs it as is right there. Okay, now originally I was calling out that there were 24 vertices. Was there anything else in here where I set the number? No, got it. So it's just going to likely going to just use the meshes. Now what I want to see on this is that I have one face that's drawing. F5. And so part of the time I won't see it at all. Like right now I can't see it, and I can tell that it's the outside because I can't see it at the back, and it's getting bigger here. Now it's getting smaller, moving off to the side. All right, so in order to get a front-facing item, technically I don't, it says it's the front face. I don't know if it's actually facing me to begin with. Okay, so I can't learn as much as I was actually hoping to. So Control KU, and let's put this one back. Control KU. Let's find out what else is going on. So program is what starts the whole thing. It's going to create a window. So window create info, WCI equals Windows create info. This is part of Veldred, isn't it? Specifically, not like Windows API or something. It is. Okay, so X, Y. Now, what's the X and Y do in here? Okay, let's find Veldred, any documentation on Veldred. So in the description inside of this video feed, I've got a link to Veldred sitting on there. And so you can use this to pull in and create your own C# app that'll generate your own, act as a renderer from a console app. However, now I need to actually study this. Documentation site. Perfect. Hey, can I get a new page? Okay, introduction to Veldred, getting started, API documentation. Okay, what am I using? This is Windows Create Info. And Control F, V, not in here. Control V. Is it just not in here? Okay, let's move back out of here. And what do we have? Getting started tutorial, introduction to Veldred. Let's start there. Wait. Oh, MIT license. Okay. I was also looking at a networking system, Tile 38, that apparently was developed by MIT. And so I was kind of curious if my choice in rendering system also came from MIT, but it's just the license. Okay, getting started tutorial. Okay, part 1. Creating a project. So inside of here, yes, we add the basic things that we need. No, this one. Okay. Now, can you tell me what the X and Y is? We create it and let's add some code. Wait, what do you mean let's add some code? Can you tell me what that code means? All right. Well, actually, if it's all open source, I'm using the library, but I've got the source code available to me too. Let's start taking a look at the source code. Where is that? Inside of here, can I search inside of this environment? Let's just go to code. I'm already in it. Source. Yes, take me to that one. X, Y. It doesn't have any documentation. All right. Oh, this is old. This is really old. At least this class is old. Maybe this... Okay, I'm suddenly having second thoughts on this one. What's the 3 years ago, 8 years ago, hasn't received any recent updates? That's concerning. Okay, 3 months ago. 3 months ago. Okay, to the source. 3 months ago to Veldred. Okay, it's just a bug fix. Got it. But it does. Its documentation comes across as fairly weak so far. So maybe not the best decision, but this one gives me a variety of different engines to be able to use. So I think I'm going to stick with it for now. Oh, and here's the engines. Okay, so let's take some considerations. XY1. Wait a second. XY100. I think this might be the top corner, like where it shows up from the corners of the screen. I'm going to try this. So I'm just going to play, and I'm expecting it to show up right around here. That is about 100. That's at 1 square inch away. Okay, let's try 2,000, not 20,000, by 1,000. So that should be right around the middle of the screen. A little bit over. Play. Somewhere around here. Okay, a little over. Stop and back to 1,000. All right. X/Y is where it starts on the screen. Okay. The window width, window title, these make sense. Let's change the name to Vigilante. Yeah. Vigilante Veldred. Okay, so now we create a window. We call Veldred Startup. So there's some class in here, Veldred Startup. Let's go take a look back at the code. Inside of here, let's do Veldred Startup. Drag this one to there. All right. So in this one, we create the Windows graphics devices. We only are using the Windows CI. So this one has multiple things going on it. Blah, blah, same thing. Create Windows, Windows CI, ref Windows CI. Oh, nice. It has reference. Cool. Okay, create Windows, SDL2 window, create window. That's this one. Okay, so we're generating it with a set of flags, which right now doesn't OpenGL. So it promises to use OpenGL in this one. Or get flags if we've got flags in there. Let me guess. Inside of here, I am passing in flags. There's an optional thing in here to set parameters. Comma. Window initial state equals window state dot, probably full screen is an option. Yes. Borderless full screen. Okay, let's try that. One giant cube. Okay. Now, if I hit escape, nothing, no interactions because there is no input on this thing. F5. No, Alt F4. There we go. And this does run from the console as the first portion of it. Okay, so now that we create the window, that means that we have a window. Now we need more. What's going on for the next step? I don't know if it actually generates the window yet. Just to create a window. I remember, what was this? I remember some of the systems back in like Windows 95 or 98, how it would, you would have a window and then you would have the GPU rendering system going into that window. But you basically did it by marking out where it was supposed to show up on the screen, not within the window. And so as you move the window, you would see the GPU screen get moved around with it, but like a frame or two behind. So that seems to be the basis of how this one is working. We create the window, and then we're also creating a graphics device, which I assume in this case implies that we are saying, here's our connection to the GPU. We're going to start using it, and we're going to render at some particular location. Now, where? In this case, the window. So we're going to be rendering to the window. We're going to pass it into the window. The options that we have. What options? Debug false. What would debug give us? I'm going to put debug to true. I doubt that's going to be anything, but it might spit information out to the console. Let's try and find out. F5. All right, we got that. And Alt F4. Nothing going out to the console. That's fine. Okay, so I don't know what the debug true means. Do we have any IntelliSense on here? Oh, indicates whether the graphics device will enable debug features provided they are supported by the host system. What do you mean by debug features, though? That still is vague. Let's put it back to false for now. Okay, swap chain depth format. I'm not entirely sure what they mean by swap chain, but I'm guessing it's a back buffer system. So they swap buffers. They've got a graphics buffer where they say, here's the frame that we're working on. We're drawing all the updates to it. And then we swap it with the one that we used to have. So we have two sets of memory duplicated for what's going on to the screen. And then we swap it, and one gets rendered out to the screen. It gets passed off to the GPU to get rendered, while the other one is being reprocessed to figure out what we're supposed to do with it. All right, swap chain, depth format, RGB32 float. Perfect. Wait, R32 float. What are the options here? Oh, there's quite a lot. R32 float. Okay, pixel format. Where does this one come in? Okay, what about the documentation site, Veldred? Nothing for pixel format. Go back, go back, go back, go back. Oh, no, I want this one. Documentation, search here. Okay, pixel format. Excellent. Now we've got information. R32 float, single channel, 32-bit signed floating point value can be used as... Oh, that's for depth. Okay, got it. So how deep it is within the rendering of the screen. So for instance, when you say how many meters back in render that the camera can render. So if you have that set to 1,000 meters back, then that's what this is. So when it's drawing to it, we create a depth item into there. And then when we want to draw a pixel for where an object is, we can first figure out, is that object even within this space? Is that pixel that's being rendered there far enough back that we even should bother drawing it? Okay. How far? This is the depth texture size. 32-bit float to determine distance. Okay. Sync to vertical blank. There's some extra things to learn on this one. Sync to vertical blank. I'll need to figure out what all these different terms mean. Well, not all of them, I guess, but whatever. But I've seen that one commonly enough. Now I need to figure out why it is. Sync to vertical blank gets us at whether the main swap chain swap buffers should synchronize to the Windows system's vertical refresh rate. This property cannot be set if the graphics device was created without a main swap chain. Okay. I want to learn a little bit more about the intent of that one. What is in rendering? What options are there, and why would we choose one over the other? So right now, I think I'm expecting to use some AI in this, and I think this is probably one of the few appropriate places to use it in education. So in this one, I don't understand this, and well, let's see. What is vertical VSync? Vertical VSync, commonly known as VSync, is graphics technology aligns the output with the render display refresh rate cycle. The monitors, okay. Wait a minute. So does that mean that if I have a screen that is splitting between two monitors, which I can't really show you guys because they can only see one screen, but what happens if I got two different refresh rates on two different monitors? I have no idea. Hello, TXH 105. Hello, 134. Got it within a minute. All right, so let's see. On this one, aligns the output of the frames with the refresh rate. That makes sense. Screen tearing occurs when the GPU sends new frames while the monitor is still in the drawing process. Okay, yeah, this makes complete sense then. All right, I'm going to put in a little note on this just for my own, to help my own learning. Okay, sync to vertical. It's already here. Aligns the drawing time to the monitor's drawing time. Blank is clears memory. I'm not entirely sure on that one, but I think I'm close enough. Blank is when it clears the memory before drawing the next frame, before sending the next frame from GPU to monitor. Drawing in the middle will trigger to change data while still pushing out to the display, causing part of two separate frames to output and overlap. Okay, next one, resource binding model. Resource binding default. Okay, let's go find information about this one. Return back to the code. Do we have something here? Resource binding model identifies a particular binding model when used to connecting to the elements in a resource layout. Okay, so what kind of options? Default, the improved binding model, which enables greater shader reuse and authoring flexibility. Okay. So right now that's set to default. Why wouldn't I want something with better improved binding? Well, first off, let's try the other one. Model.improved F5. Let's see what it renders. Yes. Oh, whoa. No. That was a problem. What was the problem? There were build errors. Identifier expected. Oh, that was a typo there. Oh, I took away this line. R32 float, which is also implying a black and white texture. Ooh. A black and white texture, since there is only one channel. All right, F5. So the change in this one is that we have the improved rendering system, but what that means, don't know. Now, one thing I am noticing is that this cube does have a crease line here, where it looks like I'm seeing inside the structure. And it seems to be almost a pixel wide for probably every other frame. But I saw no particular change come from by switching over to the improved version. Not clear to why it's improved or default. Okay, next we've got the graphics device. Okay, so the graphics device is where these are just options. We're setting up the options, but the graphics device is, my understanding, the GPU. So with this one, we are creating the GPU connection and we're gathering or we're letting it hook into the window as the point where it's going to display that on the screen. Options, nothing particular jumps out. Comma, do I have other things I can put in here? Preferred depth range 0 to 1? No. I mean, maybe that might make more. No, I don't know because I don't know how that information is being used. Like I understand the nature of what the depth texture is being used for, but I'm not sure as to the benefit of using it from 0 to 1 or floats in general, which is what I assume the option is based between. I can come back to that one later if I need to. All right, so the graphics device. This aligns. You know what? Let's do this. Create graphics device. And I guess I need the actual item Veldred startup. Doesn't have it. Okay. Okay, graphics device. Well, we're getting the graphics device. How do we generate it? Do you have an example? Look at all this stuff. So this is all auto-generated, which, I mean, I'm not sure how helpful all the auto-generated stuff is if you're not actually using XML comments to work with it. Because the XML comments basically give you the same information that's inside of here. So in this case, what is this? The Aniso 4X sampler. I'm assuming that this would end up being the what I would see if I pulled up IntelliSense from it. All right. Aligns the GPU output to the window. It also develops or generates our IO to the GPU. All right, so renderer, a model renderer. Now, in this case, this is the code that the AI produced for me, and now we're going to start jumping into this one. So we're constructing it. We need the model renderer. We need the model, which in this case is just the cube, and it's drawing this texture to it. This texture, by the way, is a CC0 texture from, I just forgot the name of the place. Pixabay. Actually, might as well take that one. Save. I just added that to the description as well. Okay, we also create a camera. So these are the things that we want to add to the scene. All right, so in this case, we create these items. We create the renderer, the model, and the camera. In this case, we are telling it to draw the model and the camera or to the camera. Is that an option being passed in, comma? Okay, so when we draw the model, we're telling it where to draw. We're giving it the draw line and we're telling it which camera to draw it on. Now I assume this means we're going to have a variety of draw calls and we should have batch draw methods. Let's take a look at this. Underscore renderer dot draw This only has a single draw call. Huh. Is that going to cost me because of it? Or is this effectively what Unity is going to be doing anyway behind the scenes when I do a batch command? Is this going to just make sure that it has all of the information at hand and then just start sending individual draw calls out to the GPU? But anyway, we do tell it to draw it. We tell it to draw the model. Okay, so why don't we create a second one? Control CV. I'm just going to put a second one in here. 2. So there's the second one. And now, what else do we have inside of here? Because right now it's just holding its own information. Does this have something that tells it to move? Date view. Great. So we're just showing the stuff here. We got size and bytes. I don't care about that yet. Model renderer. Do we do anything in here? So this is giving it the draw command. How do we tell it to rotate? Program. Oh, right there. So that's where we're rotating it. And that's giving it the rotation angle. Control CV. And let's create one more. Model 2. And on this one, we're going to say Control X. This way it'll start spinning up and down. Okay, so that should draw 2 models out. They'll basically be the same model, one spinning sideways, one spinning up and down. Save it, F5. Build errors. What are the build errors? Model 2 doesn't have current context. Oh, wait a second. It doesn't exist. Yeah. Okay, so model, where am I generating that? We've just got the information up there. Control CVV. And then we're going to call this one model 2. Technically, we don't need to generate that up here because we're stuck inside of the main for the loop. All right, but we will need a system in place where we are holding on to the model information that we're going to be drawing. And we need to draw it. We're going to need some sort of system that decides what to draw and when. Anyway, let's see if we get both of our cubes showing up inside of this. We do not. I don't see the second one at all. That is a little concerning. Okay, what other information do I have to set on this? This is... rotation angle. Can I set the position? We've got the model position. So underscore model 2 dot material and the mesh. It's referencing the mesh information with each one of these. I mean, that makes sense that it's going to, but I have control over that. So I control what the model structure is. In this case, we got the transform, which is the matrix 4x4. Now, inside of this one, we should have the actual vector 3 information. I wonder if numerics matrix 4x4 actually gives us better... Oh, the first row. Okay, third row. This one, and this is setting the X right here. So I'm going to say this one plus equals 100. Okay, so in this case, theoretically, I am taking the matrix. I'm taking the matrix 4x4 where the vector 3 is, and I believe I just took the x coordinate and told it to move over by 100, not pixels in this case, but 100 units. I'm just going to go over by 2. I don't know what its size is. That might be 1 meter, 1 pixel. I don't think it's pixels. That wouldn't make sense, but all right. F5. Let's see what it does. Do I get any overlap on the sides? No, I didn't see anything. Wait a minute. I feel like there's something else happening here. What was it? Not VSync. Scan lines. It's where it's like it alternates scan lines of what it's drawing. But that doesn't make any sense to me why it would do that. But I also am not seeing this either. All right, so we've got the camera, we got camera information. We're just giving it a camera. I guess the camera probably has something tied into it. So if I go into this one, we set the aspect ratio, we update the view projection. Is there information on exactly what we are looking at? We have a transform within the system, so we have to be manipulating that somewhere. Here, we create a look at. Okay, so yeah, we're going to look at, and we've got the target we're going to look at. Okay. And then over here, we've got the projection perspective. Okay, we're creating the perspective. That's interesting. That's more complicated than I would have thought before. Like, oh, field of view. Okay, yeah, that's easier to make sense of. Field of view, aspect ratio. So like 16:9, which I assume comes in as it's a float, so decimal. Near plane distance, so the point where it cuts off, and then the far plane, which is 100. Okay, that makes sense. All right, and then we take those two matrix 4x4s, we multiply them together, and that gives us our view projection. Okay, and Windows resized, if that resizes, then we are going to restructure the width and height of what the camera sees. Okay, that's integers. So yeah, that is width and height based on screen pixels. Oh, yeah, I created the second model, but I never drew it. That would do it. So model 2 and control S and F5. Okay, we should see both models, one going up. Okay, I see the one that's going up. Where's the one that's going around? Why do I not see both? Renderer.draw. Who controls a renderer? That's model renderer. That is us. We control it. So we told it to draw one, then we told it to draw two. We should see both at the same time. Why do we not? Okay, so in this case, we got model renderer. We got the draw command. In this one, begin. Okay, puts this command list into the initial state. The function must be called. And then when we end the command list, this is the entire frame. So in other words, if I split this out, I'm going to create two new functions. So public begin, public void begin. Let's just do draw begin. and we're going to do underscore command list dot begin. All right, and we'll do the public void draw end underscore command list dot end. Okay, now I'm going to remove these ones, Control KC and Control KC. Now the end should do more. The end should also have this one. So we're going to, let's expand this one out. All right, so draw end clears up both of those items on there. Now, when I do this, that means that inside of my code program, I should, before I start doing the draws, I need to say underscore renderer dot draw begin. And then here we go underscore renderer dot draw end. Oh, wait a second. Draw begin, there's going to be something that clears the buffer. That's got to be the case in this. So if that, let's close this one out. All right, let's go over to here, draw begin, F12. Okay, do we have something? We swap the frame buffers. That's supposed to be happening at the beginning. Okay, so we got a couple things in here that need to move to the beginning, possibly a couple things over at the end as well. Set color of target. Okay. And this one, we're setting the stencil, we're setting the pipeline. And this one, we finally draw. Okay, so it's actually all of this stuff. Control C, and then let's paste that all in here. Okay. The draw command is actually considerably less. I think something in here might be, might need to be in here multiple times. What time is it? It's almost midnight. Okay, so theoretically, that one should allow me to draw multiple times. Let's see if that is correct, and then I need to start looking at what all of these things do. All right. Back over to, oh, I just run it. Play. Build errors. Okay, no. What's the build error? Camera, model. Oh, these things don't exist. Yeah. That's all going to be at the beginning, so we need to know that information. We're going to drag that over here, Control C, and what do I need at this one? This one, I need to know the model, but I don't need the camera, so I can get rid of the camera here. So I just need the model that I'm going to be drawing with the renderer. Now over here, I don't need the model, right? Oh, I do need the model. Wait a second, look at this. It's all of this stuff deals with the model. Let's take this stuff from here, Control X, and let's put it back down over here. Okay, model, that one works with the model. All right, Control KU. Okay, so now we've got two different sets of commands. Let's go back over to not program. Oh yeah, this is in program. It's unhappy with this line, comma, and it wants the model. So underscore. But look at that. With the model, I don't want the model with it. I'm getting rid of that stuff from the model side. So over here for this one, we should only need the camera. There's no model. Okay, correct. And camera does exist. All right, so model doesn't exist here. The first one we tell it the camera. This is making more sense. Okay, Control Shift S. So now in this one, we need the camera, underscore camera. And these ones, we don't. Do I get two objects overlapping in the way that they spin? No. Why? All right, so we create the rotation. We got that rotation happening to each one of them. We're modifying the rotation. Oh, got it. We're taking the rotation angle. In other words, we're taking a default matrix 4x4, position 0, scales 1, and we're controlling the rotation factor. Model 2. So render, we tell it to draw beginning with the camera. At the end, we tell it to swap the buffer. So what else is happening here? Because I'm definitely not getting the ability to draw more than one model at a time. Draw begin, camera. So here we begin. Stop. No, I don't want that. Begin, set frame buffer. Yeah. Set full viewports. Yes. Clear the color targets. Absolutely. Okay, we set the depth target. Sure. We set the pipeline first. Set pipeline first. What does this one do? The active pipeline used for rendering. When drawing, the active pipeline must be compatible with frame buffer, resource set, and device buffer objects. When a new pipeline is set, the previously bound resource sets on this command list become invalidated. Okay. And must be rebound. Now, then bind the resource set. So graphics device.update buffer. Graphics device update buffer. The update buffer region with new data. The function must be used with a blittable value type, matrix 4x4. I'm used to like back in the 90s with the Win32 APIs using like bit blitting in order to draw graphics to the screen. And so when I see the term blittable, that in my assumption means that we can draw pixels to the screen. And it is used in a similar set. Okay, so update buffer. Now set graphics resource. What is this? Sets the active resource set. This resource is only active for, but that's working with the camera in specific. So now what does the draw command do? In this case, we update the model buffer. Okay, so this is a list of instructions. I'm assuming it gets passed into the graphics card. Command list. What is a command list called? What do you come from? If I go to command list, all right. A device resource which allows the recording of graphic commands, which can later be executed by a graphics device. Before graphics commands can be issued, the begin method must be invoked. Okay, no, go back. So the begin method must be invoked. Where is the begin method? Because this is starting to give us the exact information we need. I can get rid of that one. When the command list is ready to be executed, the end must be invoked. So over here in the draw, wait a second, did I actually clear stuff out in there? Draw begin, draw end. Okay. Draw begin, draw end. So we do have the proper things in there. We have the begin, end, end, and then submit commands should be used. Note the use of the command list is not thread safe. Access to the command list must be externally synchronized. There are some limitations dictating proper usage and ordering of the graphics commands. Okay, so this is implying the primary use of like a main thread or a thread that is specifically tuned for putting everything together into this structure. Now, we're also dealing with a double buffer, so it makes complete sense that we would have our own threads that are double buffered in choosing what to draw, what to pass over into it. And it kind of seems like rather than just individual draw calls, these would be commands that I'm passing in. So I would pass in a collection of commands about what is going to be drawn. However, those commands are also assuming occlusion. So I'm assuming that it's not like I just pass this over to the graphics engine and it will occlude things by default. I'm assuming it's going to draw every single thing I tell it to draw, even if it's off screen, wherever. Or I guess if it's out of the view space, it's just not going to draw it at all because there's nothing to render there. But it'll still take those commands. Okay, so frame buffer, let's see. There are some limitations dictating proper usage and ordering of graphics commands. For example, a frame buffer, pipeline, vertex buffer, and index buffer must all be bound before a call to draw indexed. Hey, wait a second. These are the draw commands that I was looking for before. So there's draw indexed. Okay. Draws the index. What do we have? So in this case, we've got a large... I want to see the code for command list. Where is your code? Code, we're going to go back. Command list. All right, so inside of here we have the command. Do we have a list? What is the list actually made of? So we keep adding these things. So we call these commands like, what is it? Update buffer or draw indexed. Can you find draw indexed? Oh, no, it was over here. Go back. All symbols. Draw index. No. Wait. It's not in alphabetic order. Draw indexed. Okay, so here's draw indexed. Draw index primitives from the currently bound state. Okay, what's the other one? Draw index. The number of indices, the number of instances. In this case, am I passing in an array of data? Validate index buffer. Pre-draw validation. Index count, index. In this case, oh, go back. Okay, so we have a command in here to draw index. vertex offset instance count. We're telling it to draw only one item. Is that the case? Okay, so instructions. Tell me more about draw indexed. All right, so let's see. What is this one? Draw indexed. That's not what I'm looking for. Okay, so we have the model. We're transferring this. We're updating the buffer. Graphics device update buffer with the model transform. Update the buffer. We have the model buffer. What is the model buffer? Does our model buffer only store a single value in this one? Create a factory model resource set. So model buffer. Now it's getting created up here. All right, so inside of this one, buffer description 64. What do you mean by this? That's my shader. All right. I think I'm about to call this a night because I need to study and start learning every feature of this, and my brain's going to need a rest pretty quick. Oh, what is this? Set graphics resource. Okay, I need to get some rest. All right, I will talk to you all later. Good night.